Hi, this is Mr. Nazarian. Our learning objective today: I can understand and explain the value of digits in a larger number. 5th grade standard, numbers base 10, A1. And this category of standard that we are looking at, numbers base 10, is actually a huge part of what we're going to be looking at today. So we use a base 10 system for our numbers, and what that means is that we have 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And once we've reached that's kind of a threshold, 9, once it gets above that and we get to 10, that means that the place value actually needs to move over to the left one place value and therefore is worth 10. So each time that we move over 10, one place value to the left is greater 10 times more. Every time that we move to the right a place value, it is 1/10 or 10 times less the place value previously. So what that means is when I'm looking at, and I kind of like to look at this with place values this way when we're looking at whole numbers, looking at big numbers, and you can go left as far as I can see, get to huge numbers, but every single one is divided into these three kinds of sections. We have 1, 10, 100, 1, 10, 100, 1, 10, 100, and so on as you go to the left. But you can kind of think of it, I kind of think of it as like mom, dad, and a kid or something. So every house has these same components, and that's not, of course, true in life. There's houses without any kids. There's houses with many kids. You name it. But it always, for the sake of this analogy, it's always ones, tens, hundreds in every house. But every house has a different last name. So when we're over here, these are the big ones right here. This is millions, right? Then we got thousands. This house, there's no last name. This is like, like Nene or something, and it just has first name, no last name. For those of you basketball fans out there. So these ones is just one. So I've got 5 ones, I've got 5. If I got 5 tens, I've got 50, right? If I got 5 hundreds, I have 500. And there's no last name there. It's just 555. But then as we move to the left here and we're in the thousands house, if you will, then it's 1,000. So we've got 5 in the one column, but it's got 1,000 in the last name, so we've got 5,000. Here we've got 5 in the tens. 5 tens makes 50, but the last name is 1,000, so 50,000. So in this house we'd have 555,000. And then in the millions, same kind of thing. We've got 5 ones is 5, 5 tens is 50, 5 hundreds is 500, but our last name is million. So here, if we read this whole entire thing, it'd be 555,555,555. And the thing about the place values in our base 10 system is each of these place values can only hold one single digit. So if I was to change this to 9, we're getting really close to that threshold. That's the biggest digit that it can be in a single place value. Once we go one higher than that, we can't put a 10 here, okay? Because we can only have one digit in a place value. So if we had 559, if we're just looking at this orange house here, and then all of a sudden I got one more, then this would become a 0, and that 10, instead of having 10 ones, we'd move it over to the tens place. So remember I had 50 before there, so now I have 60. So because every time that we move to the left one place value, it gets 10 times larger. There are 10 ones in 110, right? There's 10 tens in 100. There's 10 hundreds in 1,000. There's 10 thousands in 10,000. There's 10 thousands in 100,000, and so forth. So every time that we move to the left one, it gets 10 times greater. And every time that we move to the right one, it gets 10 times smaller. So because there's 10 ones in a 10, if I move to the right here, it gets 1/10 of 10. And then as we move into working with decimals, the same is true as we move to the right here. We go from 1 to tenths. Well, there are that's 1/10 the size of one whole, because there's 10 tenths in one whole. Or moving this way, if I am looking at, for example, the hundredths, there are 10 hundredths in 1/10, and there are 10 tenths in one whole. So as far as you can go to the left and as far as you can go to the right, that holds true that as we move to the left, every time we move to the place value 1 to the left, it's 10 times greater. Every time we move one place value to the right, it is 1/10 the size, or 10 times smaller. All right, so I think I beat that horse to death, and we will work on that tomorrow. All right, see you then.